Howdy, folks. This is now part 3 of my ordeal with my file servers, and it's finally over. It's finally done. So I just wanted to make this video to sort of wrap it up and explain how everything finally worked out. So this whole thing took about 2 weeks, far longer than I originally expected, but I mean, shit happens. So I just sort of quickly skimmed through the previous video. It's been so long I've already forgotten what was going on last time I had the camera out. And I was doing a scrub on Tesla because I had lost a file. So anyway, that scrub completed. And normally when you delete a file and then run a scrub, the scrub will basically clear the error. Basically, when you delete a file that's corrupted, you'll break the file name to inode mapping, and that'll cause, as you would have seen in the previous video, it'll cause it to basically just give you the inode number rather than a file name in the Zpool status output. And when you run a scrub, it should clear that up. But at the end of the scrub, which took about 10 hours, I believe, it was still there. And I was thinking, is there some bigger problem? Is there some bigger corruption going on? And am I going to have to destroy and rebuild the pool or something? So I looked through so much stuff. I tried to use ZDB to try and dump information, and ZDB was failing, telling me that it didn't really exist and all sorts of stuff. So at the end of the day, I ran the scrub a second time. I deleted all the snapshots again. I actually stopped ZFS Auto Backup from running, ZFS Auto Snapshot from running, so it was not making any new snapshots. I ran the scrub again, and another 10 hours later, it finally finished, and it did clear the error. So the pool was at that point healthy. I was able to copy the file from the backup server, from Darwin, back onto Tesla, and I was effectively back where I started. So it took a while, far longer than I needed to do. Far longer than it needed to be, of course, just because I had to do the scrub twice. But I'm not sure why it didn't work the first time. But anyway, not a real big deal, just a waste of time, I guess. So so I was doing the scrubbing, and I believe I mentioned this in the last part of this. At that point, I had a 4-port SATA host bus adapter in Tesla, and 2 single port cards in Darwin, one of them which I had just bought. And I had mentioned that the 4-port card is bottlenecked because, of course, you're putting 4 SATA 3 devices on a single PCI Express X1 lane. And, of course, that's not going to end well, even with mechanical spinning disks. So after that scrub had completed, I had this kind of sort of, I'm not going to say it's a genius idea, but kind of it was. I mean, I sort of counted the number of total ports that I had between the cards and the 2 devices, and I realized that if I just swap the HBAs around, I can get rid of this problem, because I've got the 2 dual port cards in Darwin, which totals 4 ports, but they're not bottlenecked because they're 2 per lane, whereas this one is still 4 ports, but it's all in 1 lane. And I don't care if the backup server is slow, but I care if my main file server is slow. So I thought, okay, well, I'll just bring the 2 cards into this one and the 1 card into that one, and there we go. It's problem solved. So I did this, and it took forever. And then once I had it all swapped around, booted the main file server up, and immediately I was greeted with a degraded Zpool. One of the disks was not detected. And checking the logs, the kernel logs, the disk actually was detected, but it could not be communicated with. And it was basically spewing out bus errors. And I thought this was very odd. And I traced it down to one of the ports on the brand new host bus adapter that I bought. And I believe I mentioned this in part 1 when I actually built Darwin, that I had thought I had a bad cable connecting one of the disk drives to the new SATA controller, and I swapped out the cable and the problem went away. But now that I moved that HBA to another machine, it was a different cable, everything, but the problem was the same. So I basically deduced that I had a bad host bus adapter, not a bad cable. So I had to go out and I had to exchange it for another one. Um, I couldn't find any bad solder joints or anything on it, so I'm not entirely sure what was wrong with it. But I exchanged it for another one, and the new one doesn't seem to have that problem. So yeah, I did get that resolved. But as soon as I had the degraded pool, I had to get the system back up and running, so I had to swap all the 3 cards again, booted up, ZFS recovered, it resilvered all the changed data on that disk, so it was only like a megabyte, so it was really nice and fast. And then I had to swap them all again after I got the exchanged cards, so I've swapped the cards in these things so many times, I just wanted it to end. So once that was done, Tesla was pretty much done. It had all the cards in it, they were the correct cards, and I left it that way pretty much. When Wednesday came around, because that's the day I schedule my automated scrubs, it did an automatic scrub, started at 2 a.m., and it finished in 7 hours 40 minutes, which is truly amazing because this machine has taken 25 hours to scrub for the last 3 years. So for it to scrub in less than 8 hours just by doing all this, ZFS send receive and stuff, it's just amazing. So I'm very happy. So it went from 10 hours down to 8 hours just because of that bottleneck with that SATA controller. So Tesla was all good, no more problems. I destroyed the data on Darwin and I moved it. I copied the one data set. I didn't destroy all of it, sorry. I just destroyed the one data set and then basically duplicated it back over. Again, I used the InfiniBand overnight to do that because it's like 13 terabytes. I didn't want to do that over gigabit Ethernet. So at that point, I had pretty much the same content of both machines, and I was happy with both of them. So I waited quite a few days before I actually got around to scripting everything. But that's been done, and that's kind of what I want to talk about in this video. I'm going to, in just a moment, actually start up. I'll do a proper screencast, and I'll show you the code, some of which I got off of GitHub, and some of which I wrote, which I will also put on GitHub for anyone who wants to use it. And that's basically what's made my backups fully automated, and I've tested it, and it works properly. It's really beautiful the way that this works. So the setup is pretty much done. I'm going to move this backup server. I don't want it next to the actual server, but it's just here for now. It's plugged in, and the network card is set up for Wake on LAN. So it sits off all the time, and then there's a cron job on the main file server that runs at night. I've scheduled it to run actually right in the morning. It runs at 8 o'clock a.m. So I'm up by then, so it doesn't matter. But I wanted to schedule it after the ZFS auto snapshot does its daily snapshot, which happens around 6:30 in the morning. So I wanted it after that. So I've just picked 8 a.m. Arbitrarily, but I can move that. So it runs the script that I wrote, and that script will send a wake on LAN frame to Darwin. The machine will wake up. The script will wait 2 minutes. I've given an arbitrary timeout for that machine to come up. It will then begin to poll it to see if it is indeed up and it can log in, and it will retry several times. If the server is taking longer than usual to start up, it will eventually give up if it can't reach it. But once it reaches it, it checks the status of the Z pool that's on there, and if it's unhealthy, so if it's in a degraded state, it will send me an email that there's something wrong, and it will not attempt to do a backup. It won't attempt to write new data to a degraded pool. It'll just shut the machine back down. But if everything looks okay, it will then start the incremental backup script, where it will basically look through the snapshots that are on Tesla that are not on Darwin, and it will copy incrementally each one over recursively until it's up to date. It will delete any snapshots that are on Darwin but not on Tesla, so it'll automatically remove old snapshots from the backup server, and it will do this once everything's all good. It will then just basically power off the backup server, and the whole process starts again the next time the cron job is scheduled, which right now I have it scheduled for every day, but I may make that once every 2 days, just because I don't want to totally kill the drives by constantly starting them and stopping them, but it's probably fine. So that's the way the backup system works now. Everything's logged in just a continuous log, so you can see, with dates and times and stuff. And so anyway, let me just show you the code and show you what it actually outputs, and that'll give you a bit more context into what I needed to do to make this work. So here we are logged into Tesla, and so I want to go over how I did the actual scripting for this automatic backup system. So the first thing, whenever you're doing any kind of thing like this, generally speaking, whenever I need to script something, sometimes if it's a small thing, I'll just do it myself. That way it's kind of a learning experience and I can customize it however I want. But in this case, I wanted to just search and see if there was someone who'd already done something like this before. And searching GitHub resulted in this script called ZFS Backup by, I'm not going to try and pronounce that. This is kind of an old repository. It hasn't been updated in quite a while. But this allows you to do incremental sending and receiving of snapshots over SSH. And it's got most of the functionality that I was looking for, with the exception of it didn't have support for offline machines. So it assumes that the backup server is already online, basically ready to receive a snapshot, which in my case it was not. And the other thing is that this is written for Solaris 10, and by default it will not run on Linux. So I've had to make some modifications to this to make it run on Linux, but it does run perfectly fine. And I've written my own script which basically calls this, and that script is what handles the offline, basically starting the server and all that other stuff, as well as a couple other checks. So I will post the code for at least my script to either GitHub or my blog or something. There'll be a link in the description to where you can find the code. It'll be under the GPL, of course. But I just wanted to go over the ZFS backup script, the script that I did not write, and just show you the changes that I needed to make it run on Linux properly. The first thing you need to change is the shell, because it defaults to KSH, and that's not something you're going to find on Linux. So I've just chosen Bash. It works perfectly fine with Bash, so that's good enough. You have to populate it with some parameters, as you would expect. I've set verbosity on because I log the output of this, and I like to just logging helps when something goes wrong. So the more logging, the better. And it's not incredibly verbose, so it's not like you're logging a whole bunch of useless stuff. The configuration file is actually not necessary. It's not used. I've not bothered with that. The path to the ZFS binary is not user sbin ZFS. It's just sbin ZFS for OpenZFS. So you will need to change that. The other thing is that I'm setting the remote user, basically the user that gets logged in on the backup server, as root, because you have to be root to run the OpenZFS commands. So as a result of setting this to root, which I've created an SSH key to do this login automatically, there's no need to run pfexec or sudo or any of those commands on the backup server. So I've just set this to null, basically. The way that this script actually knows which data sets to back up is it looks for a user set property, and if the property is present and set to the correct value, it will do the backup. Otherwise, it will ignore the data set. So I've just chosen, in this case, Furno Auto Backup, just so that it's nice and easy that I can spot it. It has to have a colon in it so that it's treated by ZFS as a user property. If you don't have the colon, it won't let you set the property because it's not. Otherwise, it thinks it should be a real ZFS property. It looks and says, okay, it's not. So you have to have that in there. The tag is basically what the script looks for in snapshots in order to basically, this script, I should mention that this script works in tandem with the ZFS auto snapshot
utility program, which you can install. It's a standard package, and it basically just sets a bunch of cron jobs that automatically creates and destroys snapshots on a schedule. And this simply piggybacks off of that and uses those snapshots as the points to use to do the incremental backup. So you have to have either your own script or ZFS Auto Snapshot installed for this to work. So I've just set the tag for the daily snapshots because I'm doing these once a day. Remote host is Darwin, and the remote pool is Backup Tank. I just use btank. The reason why I made the pool a different name is simply I don't want to be in a situation where I accidentally log into the wrong server or I run the wrong script on the wrong server and it erases data or something that I don't want. So by making the pools different names, if I am accidentally logged into the wrong server or I run a script on the wrong server, then it won't run basically because it won't be able to find the right pool. So I find that making them different names is always a good idea. But of course, you just populate it with whatever you used when you built the server. Just going through here, what else did I have to change? Really not that much. It's actually relatively robust. So yeah, that's pretty much all I needed to do to make their script work. So my script basically is what actually gets called by cron, and it invokes this script when ready. So I just wrote it in Bash, and it has some parameters as well. You have to give it, of course, the MAC address of the network card on the backup server so that it can send a Wake on LAN magic packet to that MAC address using a broadcast. I also have it use basically. I don't really trust Wake on LAN in large, busy network environments because it sends only one packet, and if that packet gets dropped or lost, then the machine just won't come up. So I send the actual magic packet 3 times just for good measure. I mean, there's no harm in doing it. And the third time, I actually send it explicitly to an IP rather than to the broadcast address, just in the event that there's a smart switch or something that's blocking broadcast. So I've provided the IP address, which is a static IP address. It's DHCP reserved for that server. The remote login is just root, of course, and I've given it the path to the script that I got off GitHub because it needs to be able to call that. There's a lot of echoes. There's a lot of text in this because the output of this is logged. The logging is done in cron. I've just called cron with a it just appends. Actually, if I do a tail-n 1 /etc cron tab n2. I have things in my cron tab that I can't show you, so that's why I have to tail it. But you can see I simply run my backup script at 8 a.m. every morning, and I just append the output to a log. And it's appended so it doesn't replace the log, so it's just a continuous log. If it gets to be too big, I can set up log rotate to automatically rotate the log, but I'm probably not even going to bother with that. So the reason why there's so much text is just because I want the log to look pretty. No other reason, really. So it basically wakes up the machine by sending out 3 Wake on LAN packets, and then it waits 2 minutes. 2 minutes is a fully arbitrary number. My machine does not take 2 minutes to boot, but you might as well put it, I guess. Then what it attempts to do is it attempts to log into the machine. I'm not using ping or something to figure out the machine is up because depending on the way that Ubuntu boots, depending on what stage of the boot up process it's in, you can ping the machine before it can accept SSH connections. So I wanted to go sort of whole hog. Can you log in or can you not log in? And if you can log in, it just runs uptime, just to some arbitrary program that's pretty much guaranteed to return an exit code of 0. And if that login is a success, then the server is up and we can continue. If SSH basically fails to do the login, it will return a 255 exit code. And it will basically enter an until loop until basically retries is 0. So it just gives it, in this case, 3 retries with a 30-second delay in between. So it waits up to another minute and a half for the machine to come up. If it doesn't come up after that, it simply exits and gives up. But otherwise, it proceeds. It checks the status of the pool. So if you use the -x parameter on zpool status, it basically just dumps a single line, basically says it's either healthy and returns exit status is 0, or it prints the whole zpool status output if it's not healthy and returns a non-zero exit status. So it's really good for that. The -x parameter is really good for scripting. So I've just run that and basically check the status of that. If it's non-zero, if there is a problem with the pool, I have a script. I have a mail script on my one of my app servers that basically just sends me an email that tells me that there's something wrong, and then it powers off the server by just running the power off command through SSH. It doesn't attempt to back up to a bad pool. But if everything's good, it just continues. Now, one thing that some of you will probably notice is you may say, why am I running SSH? Why am I just running this uptime command to check SSH login? Why don't I just run this command to check login? So to do, 2 birds with 1 stone. And there's absolutely no reason why you can't do that. I just wrote the script this way, and I never bothered to go back and change it. You can, the real reason why I kept it this way is because of the output status code, the return status code. In this case, the way it's written now, I can very easily tell if there was a problem logging in or if there was a problem with the pool, because they're 2 separate commands. But if I ran with just one command, then if it's a non-zero exit status, I'm not sure if it's the zpool has a problem or if I couldn't log into the server. So that's why I've made them 2 separate commands. And I know that there's ways that you can check whether it was SSH or the command, and there's stuff like that. I'm just not going to bother with it. The script works fine. If you want to change it, go ahead. It's GPL. That's the whole point. But anyway, if it's continued this far, everything's all good. It just calls the ZFS backup script. It runs this, and it logs the output of that. So this outputs to standard out. So it gets logged with this script because it's called as a child process. And then it basically looks at the return status of this script, which does actually have failure return codes, which is really nice. So you can tell if this actually did exit successfully or not. And so my script will basically just log, it's either okay or not okay. And it waits 30 seconds after the script is finished. I'm doing this simply because it gives time to flush buffers, and I just don't want any weird race conditions or things like that happening. There's no harm in doing a small delay like that. And then it just sends the power off command. It prints the time, basically it prints the time that it started and the time that it stopped, just so that you know how long the backup took, and that's it. That's the whole script. It's not very complicated at all. It's not even 100 lines, and that's with all the comments. So that's basically how it does the incremental backup, and it works really, really well. So if I actually look at the output of the log, now this is going to be the older version of the log, the older version of the script. Basically, I originally wrote it such that my script would actually have 2 logs. It would basically log the output of both of these separately. But as it's written now, it's all going to be 1 log. But anyway, one of the logs is very simple. It starts, sends the magic packets, waits, checks that it's up, checks that it's healthy. So that's the output of zpool status -x. Runs the backup. Now with the script now, it will actually, in between these 2 lines, actually dump the output of zpool or ZFS backup, but at this point it didn't do it. I probably should have doctored the log file just to show you what it would look like before this video, but anyway, too late for that. And then it's just done. So it's very simple. So if I just check for the this is what the output of ZFS backup looks like. It just basically tells you what the snapshots are. So it basically destroys old snapshots that are not present on the other machine anymore, receives all of the snapshots on one machine that are not on the other machine for each data set. It tells you how much it transferred, how long it took, and the data rate. And that's it. I mean, it's so easy. And it's fully unattended, and I love it. So, yeah, everything turned out well. No issues beyond the I think the last issue I had was the flaky host bus adapter, which didn't seem to have. I mean, it looked fine and it worked fine sometimes, but if you jiggled it, it stopped working. So after that, no more problems. Everything's fine. It's working. All I got to do is find another place to put the backup server that's far away from the regular server, and this ordeal is over. So anyway, hopefully you got something out of this video. Again, you're free to use my script if you want. You could, of course, combine the two into a single script to make it nice and clean, but I didn't bother with that. So anyway, hopefully this was interesting. Thanks for watching.